Hi, good evening. This is Rituparna Chaudhary from Thakur College of Science and Commerce, Mumbai. Now, today we're going to learn a topic called assignment problem. So, assignment problem is a part of operational research. In assignment problem, we allocate resources to the activity to one-to-one basis. Means here the job and allocation is done where jobs are given to the allocation with 1-1 basis. The most popular and effective method for solving an assignment problem is Hungarian method. Some application of assignment problem is in a factory, some products are produced with the help of different machines. One machine can produce only one type of product. So we need to find assignment of machines and products one-to-one basis. There are sales regions and sales executive. Assignment should be done in one-to-one basis to get the maximum profit. Third option is employee are to be assigned different types of job one-to-one basis, and here your target should be that method Hungarian method states that the target should be the cost minimization and time minimization. So it's basically a minimization problem. So four ordered assignment problem. Let's learn a topic four ordered assignment problem. In a factory, four workers are to be perform four jobs. Cost is given in rupees 1000. Find the optimal assignment of the workers and tasks. Is there alternate optimal solution exists? That means alternate optimal solution means that can be possible that the solutions are more than one. If yes, show the alternate solution. Now this is the table. The table shows us the worker. There are four workers A, B, C, D, and jobs are P, Q, R, S. And you can find out that the cost of each worker per job is given, and you have to minimize your production cost. So first we have to start with the row minimization in the Hungarian method. Row minimization means we have to find out which is the maximum minimum of that row, and from that minimum you will be subtracting the remaining elements. So as 40 is the minimum, so you will be subtracting remaining from the 40. Then the next row, see which one is minimum is 35. From 35 the remaining elements are subtracted. And the next C row, which one is minimum? 50 is the minimum, so remaining elements are subtracted from 50. And the last row, 40 is the minimum, so 40 is subtracted from the remaining elements. So we got this. Now after the row minimization, we have to consider with the column minimization. In column minimization, C will get the same thing will be continued for the column. We have to find out which one is the minimum, and we have to subtract that. If 0 is there in the column, so we don't need to change anything into that. See, in the first column 5 is the minimum, so 5 is subtracted from the remaining column elements. In next column 5 is again minimum, so 5 is subtracted from the remaining column elements. R and S is already having 0, so no change in that. After that, we'll try to draw the maximum number of lines, and lines which are drawn, that number should match with the order of the matrix. Here we can see that the number of lines is matching with the number of order of the matrix. Order of the matrix is 4, and the minimum number of lines drawn here is 4, which is needed to cover the zeros. Hence our solution is optimal. So as my solution is optimal, I'll give you the allocation. So how I'll start with the allocation? First I'll start with the allocation with the row which is having only 1 0. See, first row is having only 1 0 at the place of R, and D also there is in that same column one more 0 is there, so we'll cut that in the fourth row. Similarly, in the next you can find out in the D row there are 2 zeros, but we can find out that in B row there are 2 zeros, and C row also there are 2 zeros. Now this is a case of alternate optimal, because B and C the number of zeros are in the same place, so you can select either 1 0, and accordingly your optimal solution will also change. So here the alternate optimal solution is also shown. The first one, B, P cell is selected and the next one BS cell is selected for the allocation, and see, you can find out you are getting a two different kind of solutions. And if you compare the two different kind of solutions, you can see that the total number of cost will be same. Now how we are getting the total number of cost? As A is given to R, B is given to S, C is given to P, D is given to Q. Now we are going to check the first table. In the first table, A to P is given how much, A to P is given, and first table A to P is given how much, A to P whatever amount is given, we are going to consider that amount over here. See, A to P is given how, A to R is given 40 in the first column, B to S is given how much, 35 in the first column. So we'll take those cost which is given in the sum, and we'll add it up, and whatever the cost we are getting, that will be our total cost, and that cost is the minimum cost. Thank you all of you.